Question number 13. A type of firework is made by connecting two rockets facing in opposite directions. Okay, to a rod as shown. And this means what happens? This rocket will now try to go upwards. This rocket will go downwards as a result of it. This has been connected by a rod. Okay, so there's a pivot also here. So what will happen? It has been like this over here. So this will now go like this. This will go upwards like this. This will now start turning like this. Wonderful firework, right? Okay, rod is attached to a frictionless. Okay, so you have seen all this. What has been asked? Which statement is correct? The firework is in equilibrium because the resultant force acting on it is 0. See, this is what is the firework. There is a force F here, there is a force F over here. The resultant force is 0, but resultant torque is not 0, right? So therefore there is no equilibrium over here. Equilibrium refers to two types of equilibrium. One is the translational, the other one is rotational. Here translational equilibrium is definitely there because the rod will not move. So therefore this is incorrect. Rotational is not there. The firework is in equilibrium because resultant torque acting on it is 0. No, resultant torque is not 0. There is definitely F into D into 2, right? See, this is your, what is this distance here? This is D here, right? So this distance is D. This distance is D. F into D here, F into D here, both of them add up. So this is your resultant torque. The firework is not in equilibrium. Now, so far equilibrium, now not in equilibrium. Because the resultant force acting on it is not 0. No, there is a, it is not because of that. The resultant force definitely is 0, but it is only due to torque. The firework is not in equilibrium because the resultant torque acting on it is not 0. So D is the right answer.